In Colorado Springs, the rules for your boiler are different. Altitude changes everything. The real danger isn't failure. It's that your boiler could be producing silent, deadly carbon monoxide. The reason is physics. At this altitude, there's about 20% less oxygen in the air than at sea level. This thin air starves your boiler of oxygen, forcing it to work harder for less heat in a process called derating. We'll break down the physics, expose the risks to your safety and wallet, and show you what a real high-altitude tune-up is. A boiler needs a perfect mix of fuel, oxygen, and heat. Here, the oxygen side of that triangle is broken from the start. Without enough oxygen, the fuel can't burn completely. This single issue is the root of every high-altitude boiler problem. You are literally paying for fuel that does not become heat, leading to higher energy bills for a colder home. But this is not just about wasted money. This process is actively destroying your boiler. Let's look at how. Incomplete combustion creates sticky, black soot. This coats the boiler's interior, acting like insulation and forcing the system to overheat, drastically cutting its lifespan. Since it produces less heat per cycle, your boiler runs more often. This constant starting and stopping accelerates wear on every moving part, from pumps to igniters. Colorado's dramatic temperature swings amplify this problem, forcing even more stressful start-stop cycles. A system already under strain is pushed to its absolute limit. Remember that carbon monoxide threat? This is how it happens. Soot-choked vents and bad combustion trap deadly CO gas inside your home, instead of letting it escape safely. So, if you cannot add more oxygen to the air, how do you fix the combustion triangle? The answer is to precisely control the other side of the equation, the fuel. The first step is installing a smaller gas orifice. This simple change reduces fuel flow, creating the correct air-to-fuel ratio for our thin mountain air. But a new orifice is not the whole story. The pressure of the gas is also a factor. And there's an invisible force here, atmospheric pressure, that creates a completely different danger. How can you spot these issues? Look for lazy yellow flames instead of crisp blue ones. See soot near the unit, facing high bills? These are all warning signs. And it is not just the air. Colorado Springs hard water creates mineral buildup, or limescale. This chokes the boiler's internal pathways, worsening the inefficiency. If your boiler suddenly shuts itself off, that is not a simple glitch. It's the safety system detecting dangerous high-altitude conditions and preventing a catastrophe. Now, back to atmospheric pressure. The lower pressure here makes air less dense. This thin air is terrible at transferring heat away, causing components to dangerously overheat. This overheating, on top of the accelerated wear and tear we already covered, is a direct path to premature, catastrophic system failure. It is about the machine's integrity. The physics get deeper. At altitude, the flame itself grows longer and wider. If ignored, it can physically scour and damage the boiler's internal chamber. Even the fans need adjustment. They must be calibrated for air mass, not volume, to force enough actual oxygen molecules into the chamber for a clean burn. Standard diagnostic tools can fail here. Pressure gauges give false readings at altitude, requiring technicians to use specialized charts and calibrated equipment for accuracy. Orifices, gas pressure, air density, flame size, specific tools. A technician who's not accounting for all these variables is not performing a tune-up. They're just guessing. Let's connect this all together. At altitude, you face a trifecta of failure. 1. Less oxygen starves the flame. 2. Lower air pressure traps heat. 3. Too much fuel poisons the mix. This trifecta causes 3 specific outcomes: higher bills from wasted fuel, accelerated system damage from soot and wear, and extreme danger from CO and overheating. Remember derating? An expert tune-up is not just cleaning. It's re-engineering the system to perform perfectly in this environment, not the sea-level factory where it was built. So the problem is complex and the risks are severe. Now, what does the correct professional solution actually involve? A true professional uses a combustion analyzer to measure exhaust gases in real time. They then precisely adjust the gas orifice and pressure to achieve a clean, safe, efficient flame. This also means checking blower calibration for correct air mass and flushing the system to remove the mineral scale caused by our local water. It is a total system calibration. Boiler maintenance here is not a simple checklist. It is applied science. A specialized high-altitude tune-up is the only way to guarantee performance, efficiency, and safety. The result is a boiler that runs efficiently, saving you money on monthly utility bills. It also lasts longer, protecting you from sudden, expensive replacement costs. Most of all, you gain the certainty that your home is protected from the silent threats of carbon monoxide and dangerous overheating. That is real peace of mind. Do not let living at altitude put your system or your safety at risk. Contact a qualified professional to schedule your specialized high-altitude boiler tune-up today.